Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating and slightly terrifying vulnerability in TPM2-based disk encryption. It's all about bypassing that encryption, even with automatic TPM2 unlock enabled. Buckle up, folks.
Whoa, sounds intense. So, what's the core problem? Is it a TPM2 flaw itself or something else?
It's not a TPM2 flaw per se. The issue lies in how many systems use TPM2 for disk unlocking. Many setups fail to properly verify the LUKS identity of the decrypted partition. Think of it like this. The initerd, which is the initial RAM disk, decrypts the disk, but it doesn't check if the decrypted data is actually legit. It's like accepting a package without checking if it's actually yours.
I see. So an attacker could, swap out the encrypted partition with a fake one?
Exactly. The attacker can inspect the unencrypted boot partition and initerd to learn the decryption process and the expected file system type. They then create a fake LUKS partition with a known key, fooling the initerd into thinking it's the real deal. Clever, right?
Yeah, that's disturbingly clever. But doesn't the TPM ensure the system's in a known good state before releasing the key?
That's the intended behavior. The TPM checks platform configuration registers, PCRs. These registers store hashes updated during boot. The idea is that tampering with any boot component changes the PCRs, preventing decryption. But the attacker's fake partition doesn't alter the TPM state itself. It's a sneaky bypass, not a direct TPM hack.
So the initerd is tricked, the TPM is happy, and the attacker gets in? What PCRs are typically involved?
Commonly, PCRs 0, 2, and 7 are used. PCR 0 covers the core firmware, 2 covers external code, like option ROMs, and 7 covers the secure boot policy. But the article points out that many guides suggest using these, even though using only PCR 7 with a UKI, Unified Kernel Image, is often sufficient and less prone to issues from updates. It's a bit of a balancing act between security and ease of maintenance.
Interesting. So how does one secure their system against this?
The key is verifying the LUKS identity before executing the system's init process. One method is to use PCR15, measuring the volume key into it after unlocking. The initerd can then verify this PCR value against a known, signed value. Another, simpler but less elegant solution is to just add a TPM pin. It's not as elegant, but it's effective.
A TPM pin? That seems less convenient. Are there many guides out there that are vulnerable to this?
Unfortunately, yes. The author found many guides online that don't address this vulnerability. They're often well-intentioned but overlook this crucial verification step. It's a wake-up call for everyone using TPM2 auto-unlock.
So what's the takeaway? Should we all just abandon TPM2 auto-unlock?
Not necessarily. It's a powerful tool, but it needs to be implemented correctly. The article provides a checklist to ensure a secure setup, including proper PCR usage, verification steps, and, as a last resort, a TPM pin. It's about being aware of the potential pitfalls and taking the necessary precautions.
Right, a checklist is a great idea. Thanks for breaking this down. This was a really insightful discussion.
You're welcome. And remember, folks, security is a journey, not a destination. Stay vigilant, stay informed, and keep your systems patched. Thanks for tuning in to Tech Bytes and News. Have a great day, and goodbye.
Bye-bye.